In this video, I now want to look at analyzing two categorical variables. That's down here in the lower left on this little diagram. For two categorical variables, we're going to have side-by-side, or actually what I prefer is stacked bar charts. We're going to have frequencies, we're going to have conditional proportions, and then a confidence interval for the difference in proportions. So let's go ahead and see how to do all of that in R. So for my report, what I needed to look at was the composition of SES within each ethnic category. So for instance, if we looked at Hispanic, how many low SES, middle SES, and high SES are within Hispanic, so that those three add up together to 100% of the Hispanic sample. In yours, I think you're going to be looking at SES within school type. So in public school, what proportion of the sample are low SES? What proportion of the sample are middle or medium SES? And what proportion are high? Again, equaling 100% for within public school, and then similarly for private school. So we call those conditional proportions because we're looking at proportions conditioned on being in public or in private. In my case, I'm going to be looking at the SES conditioned on race or ethnic category. So just like with a single proportion, I'm going to start with the table command. The difference is, as you'll notice, I now have two variables in here. I have SES and I have race. So those are two categorical variables in my data. So I'm going to run this, and let's go ahead and look at it. SES.race.counts. Okay, so now it's showing me within ethnic category 1, and I'd have to look up to see what that was. I think that one was Hispanic, and I think 2 was Asian, 3 African American, and 4 white. 4 must be white because I see the highest numbers in there. But 1 is low SES, 2 is middle SES, and 3 is high SES. Now notice, you might wonder, well, what if I had done it the other way around? Well, that would have just been, the rows would have become columns, and the columns would have become rows. Here you go. Same information. It's just now the ethnic categories would be in the rows. All right, now for the next one, SES race percents, and I could do it proportions. All I have to do is take out that 100, but I'm showing you here how we can put in 100 times to get percents. We're going to again use the prop table, but again we're going to now enter in the counts, but this time we have one more argument we have to provide, and that argument indicates what we're conditioning on. So there's no magic about this. Quite frankly, I just try different things until I have the one that works. So I'll show you what I mean. But let me go ahead and run this, and let's see what we have. Okay, so each column is a different ethnic group, and you notice that the proportions in a column, like column 1 here, they add up to 100%, and they should. If they don't add up to 100% in each column, then we're not really doing it contingent on ethnic group. So let me show you, what if I had put in 100 times prop table SES.race.counts, and I put in a 1 instead of a 2. Now if you look at it, the hundreds are by adding across a row. So what this does is it says, of the low SES in our sample, how many were Hispanic, how many were Asian, how many were African American, and how many were white. That is not very helpful. And the reason it's not very helpful is because there are many more white people in the sample. And so this makes it look like we have so many more low SES white, when in fact it's just the opposite. What we're doing is we're doing it wrong. We're trying to figure out what proportion of my sample is low SES for each race category, but that's dependent upon how many you have of each ethnic group in your sample. So what you really want is the other way. You want it to be the proportion of SES within each of these samples, which represent these four different populations of Hispanic citizens, of Asian, of African American, of white. Okay? So if I had done it this way with a 1, I would have said, hey, that's wrong. And then I would have tried it with a 2. If that still didn't work, I might need to go back to line 34 here and switch the order of race and SES. So there's no shame in trying different things until you get it right. Now, once I've got it right, I can put in my SES race percents in my bar plot. And again, I have similar types of arguments. I have one additional one here, and this is where we're going to indicate which of the areas in each bar are SES. Let me go ahead and just run this so we can look at it. So here is my little legend that is created by line 43 here in my R program. Notice that for each sample, which represents the individuals in the population, for each sample, I have 100% of that group. 100% Hispanic, 100% Asian, 100% African American, 100% white, but now I have shaded areas to show me what proportion of each of those are SES. If I want to look at those counts, which we've already done this, but there are the counts, and here are the percents. Okay, now what I'm going to do is, before I show you what I did here to get confidence intervals, because this is a little bit tricky, I want to show you something you can do that might be easier for you. Because you don't have to do all this little calling out from the table the way I did. I'll show you how I did that, but let me show you something first that's easier. Remember when you did proportions for a single variable that you used prop test, and then you put the number in that category and then the total number? Well, we can do the same sort of thing for each of these ethnic groups. So let's focus for a moment on Hispanic, and let's go ahead and take the first one, which is low. So if I look at these data up here in this table, that first column is Hispanic. This first column's Hispanic. If you add those up, let me go ahead and add those up first. I've got 9 plus 11 plus 4. That means in my sample, I have 24 Hispanics, okay? 24 Hispanics. Well, what I did over here is I made a table based on just race, okay? In other words, rather than SES and race, I did one with just race so that I wouldn't have to do these all separately by hand. So let's look at it, race.counts. There's that 24. So there's 24 Hispanic, 11 Asian, 20 African American, 145 that are white. Okay? All right, so I'm going to now use that prop test, and now we're going to compare two proportions. So let's just suppose that what I want to compare is low SES for Hispanic and for white, okay? I want to look at the proportion of low SES for Hispanic and for white. So I can put in prop test, and then I need to put in two frequencies. One, the low SES for Hispanic, which is 9, and the other one, low SES for white, which is 24. And I have to combine those together into what we call a vector, and we do that with the C command, which means concatenate, but you can think of it as combined. So when I did one proportion, if I was doing only a single proportion, like just Hispanic low SES, I would have put in 9, and then I would have put in the total number Hispanic at 24, and there I would have had my confidence interval. But what I'm wanting to do is the difference in proportions. So I'm going to have prop test. I'm going to put in 9 and 24 for Hispanic and white. Now I need, make sure that's right, yeah, 9 and 24. But now I need the total number of Hispanic and white, and that's 24 Hispanic, 145 white. So I need to have a second little vector over here, which is 24 Hispanic and 145 white. Okay? Now it's telling me that my sample size is so small that the confidence interval might not really be 95%. That's what my warning message is, because the sample size of Hispanic here was pretty small, only 24. So let me go ahead and look at this and see if we can interpret it. I'm going to pause just for a moment. Okay, I'm back. So what we see here is that if we take Hispanic S, we get in this confidence interval, it's almost 0 on one end. It's negative 0.02, and then it goes all the way up to 0.44. So what that tells me is that there's a higher proportion of Hispanic. Here they are, right here. You can see the proportion 30, it's about 37.5%. Then there are white, okay? But it's possible that if we were to look at the nation, that we'd find out that there would be either very little difference. Notice this is only negative 0.02 between the two, or it could be as high as Hispanic having 44 percentage points higher low SES than whites do. So from the sample, I say Hispanic have a higher proportion of low SES than whites, but it's not enough to make me 95% confident in the population, although it does look like it probably is higher percentage low SES, but I can't say that really with true 95% confidence. If I took this to 90% confidence, I bet it would work out that way. Let me try it. So I'm going to add confidence level equals 0.90, and in that case, sure enough, that tells me that the higher rate of low SES in Hispanic is somewhere between about 1 percentage point higher than white to 40 percentage points higher than white. Okay, so the evidence is showing me higher proportion of low SES for Hispanic. It's just a matter of how confident we can be in that. All right, now let me show you what I did here. Because this is the command that I use down here. This one is actually comparing, I'm comparing, instead of Hispanic and white, I'm comparing African American and white. And let me show you, let's go ahead and do that real quick by hand. African American low SES 11. And 24 white. Okay, so prop test. Come on, here we go. Prop test. So make a little vector, 11 for African American, 24 for white, and now I need to make a vector for the totals. And that's 20 African American, 145 white. Okay. And so that difference is somewhere between 13% higher, percentage points higher, low SES for African Americans, all the way up to potentially 64 percentage points higher. So clearly, higher proportion of SES, low SES for African Americans than for whites, both in the sample. In the sample, it was 55 versus 16. That's a difference of about, what, 40? Okay, so about 40 percentage points higher, low SES for African American. In the population, that's somewhere between 13 and 64 percentage points higher, low SES for African Americans than for white. Now, the way I did it here is harkens back to this little table up here. Okay, there's my little table. What I was doing was in the first row, I was taking the third and fourth columns. So in the first row, taking columns 3 and 4, that's all this says here. In the SES race counts, take the first row and columns 3 through 4. The colon means to take it through that. So there it is, first row, columns 3 through 4. And then in the race counts, which remember is our total number in each race, I'm just taking 3 and 4. So that's what this is. So that's a little bit mysterious looking, but gives me the exact same thing. There's that 13 to 64. The exact same thing, but if you want to just put it in by hand, put those numbers in by hand, that would be fine. Now let me think about yours for a minute. You're going to be doing SES within school type. So instead of having all these multiple comparisons like I do, where I'm doing low to high, middle to high, doing it for African American to white, Hispanic to white, Asian to white, and so forth. Instead of that, you're just going to have low SES public-private, middle SES public-private, high SES public-private. So you'll just have 3 of these. Now I'm just showing you 3 of these here, but I really have a lot more to do for my report because I have 4 ethnic categories. You only have 2 school types. Now once we, if we want to move on to quantitative, I guess we should move on to another video. So let me go ahead and stop this one and post it, and then we'll look at the next one.